Our job is to find the derivative of y is equal to the parentheses of x plus 5 to the x exponent. So we're going to utilize a couple of things. One is that if we have a function e to the u exponent, that y prime, or the derivative of that, is going to be e to the u times the derivative of u, or u prime in our case. The other thing we're going to utilize is that if we have x, we can write that as e to the natural log of x. So in our case, we have y is equal to the parentheses of x plus 5 to the exponent of x. We're going to rewrite this as e to the natural log of that thing, which is x plus 5 to the x exponent. Using our rules of exponents and logs, we're going to move this exponent to the front. So we're going to find y is equal to e to the x natural log of x plus 5. Now we're going to take our derivative, y prime, and realize that we have e to the u, so we're just going to rewrite that e to the u. And then we have to multiply it times the derivative with respect to x. We got to get our u prime of x natural log of x plus 5. And really truly our final answer is going to be y prime. Remember that this part right here represents our original problem of x plus 5 to the exponent of x. And then now we just need to go find this derivative right here. So let's do that over here. So we're going to have x times the natural log of x plus 5. Notice that this is a product. We're going to use this as u and this as v. So when we're finding our derivative, we're going to have u times the derivative of v, which is going to be 1 over x plus 5, plus v, which is the natural log of x plus 5, times the derivative of u, which is 1. So we're done. So we're going to see that this part is going to be x over x plus 5 plus the natural log of x plus 5. Remember, this is our derivative of our u. So y prime is equal to our original function, x plus 5 to the exponent of x, times the derivative of x natural log of x plus 5. So when we do that, we're going to have x over x plus 5 plus the natural log of x plus 5. And that's our final answer. The next problem we want to solve has to do with our boat sailing. So the first thing we are asked to do is to find an equation with theta. So we have our angle here. So what we're going to do is say from this point that I can find tangent of theta to be 150 divided by my adjacent side. So we're going to find that tangent of theta is equal to 150 over x. Now for theta, what we're going to do is we're going to actually sit there and say that theta is equal to the inverse tangent of 150 over x. So that answers the first part, which is an equation in terms of theta. And then it asks us to solve our problem by using that equation. So what's happening is x is changing, and we want to know how fast our angle is changing. Because notice that if my boat is here, my angle will now be this angle. And it may not be the same as that one that we originally started. And we can clearly see that as our boat gets really close, that this is actually getting really big. So we know that our angle is changing. So we need to go find d theta with respect to time, dt. So in our case, we need to go find the derivative of the inverse tangent. So let's come back over here and review that. So if we have y is equal to the inverse tangent of u, then y prime is equal to 1 over x squared plus 1 times the derivative of x. In our case, we're going to be using u, so this should be a u right here. So going back to ours, we're going to see that we're going to have an answer of 1 over 150 over x squared, the whole thing squared, plus 1 times our derivative of 150 over x. So let's take a look at that. So 150 over x can be written like this. So when I take the derivative of that, we're going to have negative 150 x to the negative 2, or negative 150 divided by x squared. So we need to multiply this times a negative 150 over x squared. So when I do the math for that, we're going to find that at the top we're going to have a negative 150, and at the bottom we're going to have 150 squared over x squared times x squared plus 1 times x squared. So I did the distributive property of my x squared into this denominator. So when we do that, I have a negative 150 over 150 squared plus x squared. So remember, this is our d theta over dt. This is the rate in which the angle is changing with respect to our x value that we have here. So what happens now, our job is to go find when is it changing when x is equal to when x is equal to 400. So we now need to just type in 150 over 150 squared plus 400 squared. And whatever value that is, that's going to be our d theta dt. And that concludes this video.